to make this as entertaining as possible, and I'll be sure to end before 5:30. So my talk will be about the key challenges and lessons learned from testing a new trading system. I'm with Boerse Stuttgart. My name is Matthias Burghardt. I'm head of business development there, and I've been at Boerse Stuttgart for over 10 years now. And so some of you might have heard that Boerse Stuttgart has introduced a new trading system last year after a 2-year implementation project, and that's why I'm giving this talk today to talk about the key challenges that might be common for all of these implementation projects and our 10 best lessons learned from testing. So, short agenda. I'm giving you an overview about Boerse Stuttgart. Who are we? An overview of the Xitaro project. Xitaro was the project, well, what we call the project, and which is now the name of the trading system, and our 10 lessons learned. So where exactly is Stuttgart? Stuttgart is not Frankfurt, and we are located in Stuttgart. So we are there. Stuttgart is in the southwest of Germany. It is actually the capital of the state of Baden-Württemberg. The exchange itself is more than 150 years old. So the exchange was founded in 1861. And but when you think about Stuttgart, you are not thinking about the exchange usually. You're thinking about Porsche, you're thinking about Mercedes, or you are thinking about Bosch. So there are many industrial companies around Stuttgart, and Boerse Stuttgart is there since 1861 to help these industrial companies grow. And so especially in the early days when these companies were traded at the Boerse Stuttgart, in the recent years, or let's say 20 years ago, Boerse Stuttgart focused on a market, on a business model targeted towards the retail investor. So this is actually our niche we are trying to be good at. And so what kind of things are we doing in Stuttgart? Boerse Stuttgart is actually Europe's leading market for securitized derivatives. So securitized derivatives being structured retail products, being warrants, certificates. So in 1999, Stuttgart founded the EUWAX segment for securitized derivatives, and the EUWAX stands for European Warrant Exchange. 2008, we acquired the Nordic Derivatives Exchange, which is headquartered in Stockholm, and together we have about 1/3 of the market share of exchange trading in these products. So Boerse Stuttgart is special in some senses. If I tell you that we actually list more than 1.4 million instruments, you might be surprised. You might not be surprised because you've heard of that, but there are actually almost 1.4 million securitized derivatives listed at Boerse Stuttgart, which can eventually be traded. So this, of course, poses some challenges on performance and, of course, on performance testing. So, but Boerse Stuttgart is trading all the range of securities. We have debt instruments, equities, investment funds unit, ETF, ETP, ETC, and so on. So, looking at Europe, we are actually among Europe's top 10 stock exchanges in terms of turnover. So, of course, the turnover comprises not only the equity turnover, but also the bond fund, and of course securitized derivatives turnover. And being number 9, we are actually larger than on other national stock exchanges like Warsaw, Vienna, Dublin, Athens, Budapest. So that's us in a nutshell. And so how did we started the whole project? I have been personally involved in launching and preparing this project since 2011. So it took rather a long time to start with implementation, and for Boerse Stuttgart that was not an easy decision, because that was the largest implementation project we've done forever. So when we started this whole deliberation of introducing and implementing a new trading system, where were we? We were running on Xontro. Xontro is a trading system that was built by Deutsche Börse, that belongs to 7 regional exchanges, and is still running their business. But it was almost 25 years old. It was a host-based system. Governance was shared, so every of the 7 shareholders had an equal part of the ownership. And there was, of course, a high degree of dependency among those shareholders. So there were a couple of things we wanted to achieve with the implementation of a new trading system. First of all, we want to be flexible and independent of the decisions of the other exchanges, of course, because they were co-owners, but they were our competitors as well. And we want to be flexible to make our own decisions when to develop the system further. Then we want to have competitive costs. Being on a host can be competitive, doesn't have to be, especially if you have to pay more than the half of the cost that arose, because we had so much trading activity going on there, but we shared only 1/7 of the power. So that was also something that we wanted to change. Then we want to have a state-of-the-art system. So what is state-of-the-art? Some people will tell you that, of course, an IBM host system is still state-of-the-art, but I'm not so sure. It is more and more difficult to find COBOL developers who are developing your code. So we wanted to move to a new trading system, and that actually has new program language. So what else did we want to achieve? Faster innovations. We wanted to bring innovations faster to the market. Do not wait for the other shareholders, for example. And we wanted to be, in a nutshell, our system future-proof. So that is what we wanted to achieve with the project Citaro. And after a 2.5 year preparation period, we ended up in an agreement with NASDAQ, providing our new trading system. So doing a project with them for over 2 years. And our trading system has gone live last year in September, on the 20th of September, after a 2-year implementation project. So this is the overview of the project. I won't bore you with the details, but just very shortly, I was involved in 3 of the 5 streams. I was head of stakeholder management, so that's the stream where all the onboarding and discussions with stakeholders took place. I was head of functional design, leading the design phase. I was head of test and acceptance. So at some point in the project, I took over this stream, and I was deputy project manager with overall responsibility. So, and today I will naturally focus on the test and acceptance stream, what we did there, what we didn't do, what we should have done, and our lessons learned. So the test and acceptance stream, this is just a percentage summary of how much effort went into each stream. Although I have to say the stakeholder management stream seemed to be a much larger effort, but that's another story probably. Stakeholder management was a crucial part of this project. I think is a crucial part of every project. You need to align, you need to manage your stakeholders, especially the trading participants. There were so many variations of stakeholders who you had to constantly monitor and provide information with, and so on. So that was 4% of the overall effort underestimates the importance of that stream. But if you look at the test and acceptance stream, 36% of our resources in this project went into that stream. After all, I think it seems to be fair. It's about the same effort that went into technical design and customization. But in hindsight, it was okay. But at the start of the project, we did not think that it was so much effort in this stream. So this is an overview of the 2 years implementation project. So we started in 2013. We had a 6-month detailed design phase, which was really crucial to the project because we really tried to nail every functional requirement down. Then another crucial aspect of the project, we started with the implementation, or NASDAQ started with the implementation parallel to the detailed design. So we've done it in batches. So once one batch was done and signed off, then they started implementing it, just to keep the 2-year timeline. And at the same time, we started with test preparation. You cannot start early enough with test preparation. So test preparation went for 5 months, and then some beta tests were done, because with the early implementation start, we agreed to receive beta deliveries, to beta test them, and to give early feedback. I'll come later to that. And we started with early member tests, also about a year before go live. Then 1 year before go live, we had the system integration test, the user acceptance test, and also some regression test to cater for some other correction releases shortly before go live. At the beginning of the project, we have not counted with so many correction releases at the end, but it actually showed the flexibility of your supplier to be able to play in some releases shortly before go live. In parallel, there was a hardware and network setup, and in parallel also there was the cutover concept, member onboarding, member certification, some of which I will touch on later. The 10 lessons learned. First of all, key challenges. And I tried to assemble all key challenges onto one slide, and it's really high level, and everybody will notice, okay, these are really the challenges that you need to think about in this kind of testing scenario. Test case design, when to start, how to do it, when to start acceptance test preparation, and how to do it. Which guys do you need to do that? How much can you actually outsource, and how many functional guys from your internal crew do you need? Do you do beta testing, and who do you need for that? And how does the effort spent in beta testing relate to the results? And we come to test automation. We have definitely thought about test automation and trying to find the right level of automated and manual tests. This is also closely related to regression testing, because we used the first regression test even before go live, and how to track the defects in all testing activities. And then we come to the test environments that also involve non-functional testing and early member testing, because you needed to have dedicated test environments for early members to test. So these are kind of the 10 challenges that I tried to think about and put into lessons learned, into our 10 lessons learned that are falling now. Lesson number 1, that relates to the test case design. You cannot separate functional design, test case design. It sounds very simple, but we've learned our lesson there. Usually what you could do is you write your functional descriptions, approve them. Then you start with test case design with a total different crew, from scratch. You look at the functional descriptions, build your test cases, and then at the end you test. You could have done that, and we tried to do that. However, we found the approach of doing it in batches much better, because I'm not sure whether that's the way every supplier works. We've done functional descriptions covering a functional area. So once we've signed off on one functional area, we tried to start the test case design immediately. And after that, we could do the testing, but we could also gain some contingency if the test case design took a bit longer. So this is actually something that we tried. We haven't really achieved it to 100%. Why is that? Because there's an alignment between the functional and test experts is necessary. And while the functional experts were doing the design, there was no resource left who could start with a test case design. And I think that is an inherent problem here, that you underestimate the resource need for functional experts. In other presentations today, I've seen the different roles of, okay, that's the guy who knows the functionality, that's the guy who understands test case design but knows a bit about functionality. That's the guy who programs the test cases and so on. So I think you need to have those roles, but you will run into conflicts because the business people are really a scarce resource. And they complained a lot during our project. A lot of work to do. So, but this is actually, in hindsight, how we should have done it in batches and right away once you have signed off the functional descriptions. Lesson number 2 is about the acceptance test preparation. So there is a review cycle, or we have implemented a review cycle. So the test cases should be drafted, then reviewed in close cooperation with your supplier, updated and approved. We made one mistake, I think. We tried to do test cases from in a bottom-up approach. And this could really lead you, or this led us to have lots of test cases and really a high number of test cases that couldn't be handled anymore at user acceptance test. So what I would suggest in hindsight, and what we've done, or what we try to correct during the project, is you need to start from the top. So a top-down approach, first you need to come up with the acceptance test specifications. It's really just one sentence. Okay, what exactly would you like to test? What's it about? Yeah. And then you start and creating these top-down test specifications, get them to the supplier, let it review, update it, and approve it. So once you have done that, then you can refine these test case specifications. So then you can start writing the acceptance test procedures. That's for each specification. You write, okay, click there, do that, look at this, value XYZ must be 12. And this way you can make sure that it's really covered, that you cover your area that you think you have to cover, and not trying to build millions of test cases that might not be used at the end in user acceptance tests. Once you have the ATP and reviewed, approved, then you can start on the acceptance test plan. The acceptance test plan actually says that, okay, in which week of the user acceptance test will I do which test procedures? And then at the end, you have the acceptance test plan detailed, and then it's really written, okay, Tom does this, Linda does that, and so on. So that is actually how we should have done it. It's not how we did it. But in hindsight, we tried to do everything at once. It was probably not wise to do it. So next time I introduce a new trading system, I start with acceptance test specifications first, and a top-down approach. Lesson number 3, it's about outsourcing. In our market is special, as I said. We have 1.4 million instruments, and of course our market is about very illiquid instruments, low liquidity instruments. It is a market with a QLP, a quality liquidity provider, who helps in determining the exchange prices. So there is lots of complex functionality as well. So what we found, and we used an outsourcing provider, an outsourcing partner to help us with building and executing test cases, is you should choose wisely which functionality outsiders could actually test. And what I've done here is I've sorted some functionality according to complexity. And so on the X scale, you can see the percentage of the functionality or the test cases that actually were executed by functional experts. It's the light blue, and by test experts. That's the outsiders, I'd say. And for example, when we have a very high complexity, we have done it on our own. Why? Because there's so much knowledge that you need when executing these test cases. There's, of course, a trade-off. You can describe everything in every detail, but that would probably cost too much to describe it. Then you'd rather do it on your own. So I think there must be a healthy trade-off between using functional and test experts. So that functionality was an example of trading halls. It reached really lots of areas in the system, whereas GUI user configuration or user interfaces especially could be very well tested by outsiders, because it's quite easy to explain, it's easy to do. So overall, we ended up with 47% tested by our own guys and 53 tested by test experts. I think what we've learned here is you can tell, to a certain extent, you can tell a business guy how to test. But it's probably harder to tell a test guy how the functionality works in detail. So that's a trade-off that you have to find an answer for. So the next lesson is about beta testing. As I said before, we got early beta deliveries, and this was supposed to be a help for, of course, both for us to know if the software provider has implemented the functionality right, and of course a help for the software provider to get early feedback. So we were kind of guinea pigs here. So we had 6 beta releases, and this is the number of functionalities that were actually delivered. So we started with 7 functionalities, then 14. So it was really an increasing number of functionalities. And so at the last beta delivery, so we had all the functionalities delivered. We underestimated the early beta deliveries. So this is the effort we should have spent, because beta test effort spent very early is effort spent very well, because the supplier gets early feedback, then he can increase the software quality in the beta deliveries, and your people are happier too. So what we've actually done is we have put a very low effort on beta deliveries, and as we're in the middle of the process quite surprised how bad the software was. And if I say bad, it's relatively bad. I mean, Nasdaq is a good provider, so for the camera. But you know how software is. If you're getting better releases, it's better releases. And there are bugs, of course. But in hindsight, I think we should have spent more effort at the beginning, and so the software quality would have been better in an earlier stage. But in the end, of course, it's about resources, if you have the resources or not. So it would have been a stretch as well. What about test automation? We did test automation from the very beginning, and I think we're glad that we've done it. And it can actually free up valuable experts if you do it right. So I think, well, I've prepared some pros and cons from my point of view. These are, I mean, as the test automation expert panel was right before this talk, I don't think I need to go through them. I think what I mean with if you do it right, you should not at the beginning, at the start of the project, you should not try to automate all test cases. Why not? Because functionality can change. If you change functionality, you have to change the test case automation, and so on. That is costly, and then you probably cannot gain so much out of it. But what you should do is to automate butter and bread test cases from the very beginning. Because if I look at the different releases that we've had, and this is actually a graph that shows how many test cases we've executed during the acceptance test 1. We had 2 acceptance test phases during the AT2, and in subsequent regression tests before go live. So in a total, we had a total of 10 deliveries that had to be tested, officially tested and approved. And so we were kind of glad and that we had about 1,800 automated test cases that covered our basic bread and butter functionality. And that actually didn't change a lot. So it's when you send in orders get executed, trade reports. You should do that. Or in such a project, you should do that from the early stages. Talking about the regression testing. So we've called it regression testing, although it was before go live, but it was actually a regression testing after our acceptance test. So we started with 6,500 test cases that were used in the acceptance test, and then we created a regression test set, because we felt that not all of those test cases that we've actually used in the user acceptance test were suited for regression testing. So what we did is we applied some criteria. So one criteria was the functional frequency with which that was used in the system. The damage potential, if something goes wrong, how important it is, what's the potential damage. And the defect frequency, have we in a certain function experienced lots of defects in the past? So we came up with values and divided our test set of 6,500 into two test sets. One test set was actually sent to test case heaven, and the other test cases, we thought about, okay, which one of these could be automated? So is there a possibility of automation? And we found that these butter and bread test cases, like order execution and so on, order routing, that these were quite well in the regression test set. So we created a small regression test set that can actually be run in a couple of hours, including 1,800 test cases. We created another test set that actually comprised the small one. So we created the medium regression test set. The difference is that there are a couple of hundred more test cases that also require manual intervention. And then we have the large regression test set with 4,300 test cases that is actually used at each major release today. So this is the regression test set creation that we have applied here. I've talked about early member testing before, and I cannot stress how important it is to start early with member testing in order to avoid surprises. What we've done is, and of course due to our close stakeholder management, we try to find pilot an early member that could actually test our system. So that we called it early member tests. And so we've incentivized the members by promising them rebate on future access fees. And you cannot believe how many members wanted to do early member testing. It was really a success. And so many members got on the system early, tested, found a lot of bugs as well. Bugs that we would have never found probably. And they were kind of ready a couple of months before go live. I don't know what had happened if we hadn't done this. There are always members that do not test or do not test enough and then have problems a week before go live. That happened as well. But 90% of the members were really well prepared. And in addition to the early member test and member readiness checks that we provided, we had some dress rehearsals. So we had a total of 4 weekends of go live rehearsals that, of course, we required members to do, or to actually do one of them, and if they were successful, then they didn't have to do it again. But all together, member testing was really a success story, and we onboarded about 90 members. And please remember, we had a big bang migration, so everybody had to do something in order to connect to the new system. And also remember, we are just number 2 in Germany. So we are not a monopoly. So it's harder to convince members to go with you if you're not the incumbent exchange where there's no way around it, right? 3 points to mention. Defect reports by members. That's what I said. Very, very helpful to detect all errors. We have detected some errors only by member testing. Risk of delays is removed because the members are onboarded early, and these structured dress rehearsals, they are definitely a must before you go live. Some of you call it mock go live. We call it dress rehearsal. I think the outcome is the same. Speaking about test environments, I've heard some other guys talk about test environments. We had actually 4 test environments during our project. So we had one that was called the simulation environment that was actually a production-like hardware, based on production-like hardware. And I would always do that again. You need to have one test environment that has exactly the same hardware configuration, especially to do the performance testing. Then we had the external test environment, internal test environment. One of them planned to be made available to members, has never been, but that's another story. And the internal test environment for our internal software development. And we even got the flexibility to have a fourth environment just for the user configuration. User configuration is a very difficult thing. You really have to be extra careful to do that. So we had set up a whole new environment. It was a virtual environment to do the user configuration. So let's look at non-functional tests, performance test. That's a funny story because how we planned it was looking at the SLA, looking at all the figures in there, trying to come up with test cases that would cover all the SLAs, and thought we were fine. How we should have done it. We should have analyzed the business day activities according to the daily cycle, jointly with the supplier, of course, and bringing our knowledge of our functionality into the room, and detect all the business relevant performance parameters that might not be covered by the SLA, and that is one of the problems that we incurred. What we did nevertheless, we spent one day trying to break the system with bombs and flashes and laptops and everything. We discovered something there, but we ended up on the first day with a performance problem, actually. Wasn't too bad. We did not have to shut down the system, but when 1.4 million instruments were opened, when the order books were opened, plus there was some other activity going on, it was kind of slow. So we fixed it very, very, very quickly, but this is something that we could have detected with more business-like business day activity tests. And last, defect management. I really don't want to go into the slides. I just wanted to show you how we did it and how we kind of analyzed the incidents, the resolved incidents, the created incidents in a structured way. So we created the slope of both and then calculated an average net reduction of incidents that were expected to happen during the 81s. I just want to point out that during the acceptance test here, we had a daily report of all the incidents, of all the defects solved, incidents found, and a projection of at which day, with a constant net reduction rate, we would be defect-free. So in order to make, for the project management, to make the decisions how to, if the test phase needs to be extended, if supervisory board must be included, and so on. So this is really just lesson number 10 that we have learned. We have spent a lot of effort on reporting, and in hindsight, I think it was worth it. It was worth it. And so at the end, we made it. September 28th was a go live. Some obstacles that I shared with you at 9 o'clock, so performance, but at the end, we made it over the day, and I think we are quite proud of this achievement. And I'm glad I could share some insights with you guys. And thank you very much for your attention. I'm sorry that I had to rush through some slides, but I unfortunately have to catch a train to get to my plane. But thank you very much, and it was a pleasure to be here.